Hello, this is the fifth and final video of our Omniot SoftHub platform demonstration series. In this video, we'll again use the first example as a starting point. We'll alter the functionality somewhat, though, to introduce several new objects and concepts. We'll be introducing counter, averager, cache, and user report objects. And as with the previous demos, we'll go through the process of creating the configuration file, and then we'll quickly do a live demonstration. We're again going to connect to our same ANT and Bluetooth low energy sensors. However, we'll take a different approach to how we report data to our AWS packet capture server. We're going to sample our Tempi sensor's temperature reading every 30 seconds to create and maintain a 5-minute moving average of its value. We'll also maintain a cache of the 10 values used to compute the average. Every 5 minutes, we'll create a custom packet in XML format that will report only the most recent light readings from the sensor tag, the current temperature reading from the Tempi sensor, the average temperature for the last 5 minutes, and the 10 temperature values we used to compute the average. So we'll again start with the example 1 configuration file, but we're going to delete all the event, rule, and action objects. We're only left with our system options, which were modified to auto-connect to our sensors, and our 2 sensor stream object definitions. We'll start by creating a counter object that will keep track of how many samples we've taken at any given time. We set its initial value to 0 and give it a modulus of 10 so that it will reset to 0 every time we have 10 readings. This will come into play later when we define a state object to check the value of the counter to determine when it is time to send our custom packet to the remote packet capture server. Next, we create a data averager object which will maintain our moving average. We specify what sensor and sensor value we want to average and give it a sample count to set our moving average window. Similarly, we'll create a data cache action object to cache the values we use to compute the average. Again, we choose our sensor and sensor value, and lastly, we set a number of values to hold in the cache. It should be noted that cache objects are circular and operate in a FIFO fashion, so our cache will always consist of the 10 most recent temperature readings. Now we'll create our sample interval timer. We create a continuous timer to expire every 30 seconds, and we associate an event object to be queued every time the timer expires. When executed, the Update Data Averager action object will update the referenced averager object with the reading from its reference sensor value. The Update Sensor Data Cache will update the reference cache object similarly. Next, we'll create an action object to increment the counter we created to keep track of how many samples we've taken. Each time we take a sample, we'll increment our counter by 1. We'll need to add one more action object, but first we need to define our custom packet contents by selecting the Reports node and right-clicking and selecting New. Here we give our report a name and choose its format. We've chosen to create our reports in XML. Next, we'll use the buttons to the right of the Report Items dialog box to add our packet contents. We'll first add the most recent light sensor reading from our sensor tag sensor. Followed by the most recent temperature reading from our Tempi sensor. Next, we'll add the data averager value we previously created. And finally, we'll add the 10 values we've cached that were used to compute the temperature average. Now we'll create a counter value state object that we'll use to check our sample counter and see when it loops back to 0, indicating we've taken 10 new readings. we'll create one final action object which will forward our custom packet to our remote packet capture server. We now have all the objects we need to create our rule set. We add an app starting event object to trigger the execution of the rule we'll use to initialize any objects we've created that need initializing. So here we'll create and initialize our averager, cache, and counter objects, and lastly we'll also start our continuous timer. Next, we'll create a rule to be unconditionally executed every time our sample timer expires. In this rule, we'll update our averager and cache objects with the most recent Tempe temperature reading and increment the sample counter. We'll add one last rule object, also triggered by the expiration of our sample timer. This rule object will only be fully executed when our is10th_sample state object is true, which is to say only every 10th sample or every 5 minutes. When we're on our 10th sample, we'll execute our action object to compose and send our custom packet to our remote packet capture server. We should point out that this is one situation where the order counts in terms of how the rules are evaluated when our timer expires. Putting the rules in the opposite order would cause our reported data to always be delayed by 30 seconds. And that completes the rule set required for the 5th demo. So now we'll copy over our configuration file and restart the SoftHub daemon, and then jump over to our remote desktop session and wait for our custom packets to arrive. As in the previous videos, we have our ANT Tempe sensor and our Bluetooth Low Energy Sensor Tag sensor connecting to the SoftHub application running on a Raspberry Pi. The Raspberry Pi is connected via Wi-Fi to our router and is using that connection to send our custom packets to the remote AWS packet capture server. The laptop has a remote desktop session to our AWS server where we can see the packets as they arrive. For this example, we've shrunk down the font so we can get the whole packet on the screen. We're going to speed up the video since packets only arrive every 5 minutes. Here's our first packet. So let's zoom in on our custom packet and check out its contents. The packet consists of a general SoftHub packet header, followed by a custom packet type header, followed by the sensor tag light sensor's latest value, followed by the Tempe sensor's most recent temperature value, followed by our computed 5-minute temperature average value, and lastly we've included the 10 values we use to compute the average temperature. That wraps up our 5th and final video. We hope these videos have given you some idea of the power of the SoftHub's rule engine. However, we should point out that what's been presented here is literally just the tip of the iceberg. For a complete list of object types currently supported, check out the SoftHub configuration guide linked in the video description, and feel free to contact us with any additional comments or questions. And thanks again for taking the time to check out the Omniot SoftHub platform.